Lecture of arithmetic, geometric and harmonic means. Seeing the recent trend of the problems, especially in mains and advanced both, let's see how we can integrate these concepts with different branches of mathematics with the very basic ideas. So just to recapitulate, since all of you know, arithmetic, geometric and harmonic mean of two positive real numbers, let's say a and b, is defined as, I am denoting arithmetic mean as a2 since we have two of them. So it's a plus b over 2. Similarly, geometric mean is g2, which is root over ab. And harmonic mean h2, we define it to be 2 by 1 by a plus 1 by b. So based on this definition, it's very obvious to conclude g2 square value, which is a into b, can be written as a plus b by 2 into 2 by 1 by a plus 1 by b goes to ab, a plus b. So you can clearly see a plus b will cancel out, 2 will cancel out, and we'll have ab equals a. So g2 square is going to give me a2 into h2. In fact, gn square will be n into hn if we'll have n terms. So gn square is going to be an into hn. How will you define gn square for n terms? So an will be a1 plus a2 till an by n, and gn will be a1 a2 an to the power 1 by n. Similarly, hn I can define by n by sigma 1 by a1. Okay, these three means also satisfy interesting property called AM, GM and HM inequality. So A2 is greater than equals G2 is greater than equal to H2. अब इसको प्रूव करना बहुत ही proof is very easy because you can start with a minus b का whole square greater than equal to 0. Okay, and then it can be written as a plus b whole square is greater than equal to 4ab. Now you can take a square root on both sides because ab is strictly positive or better than or negative. तो वहाँ से automatically it follows a plus b by 2 is greater than root ab. So it is AM GM inequality for two members. We can extend it for n members either using Jensen's inequality or by principle of mathematical induction. तो वो अभी हम कर नहीं रहे क्योंकि फील लेना है क्वेश्चंस का. Again, how will you prove G2 and H2 inequality? That's very easy. We can replace A with 1 by A and B with 1 by B. Okay, and it's fundamentally AM GM only because then we'll have 1 by A plus 1 by B by 2 is greater than equal to root over 1 by AB. So it is specifically what we have. G2 is greater than H2. Now let's see हम क्वेश्चन को कैसे इससे कर सकते हैं. तो मान लो मेरा फर्स्ट क्वेश्चन जो है वो है अरिथमेटिक ज्योमेट्रिक एंड हार्मोनिक मीन्स ऑफ टू पॉजिटिव रियल नंबर्स आर द लेंथ ऑफ साइड्स ऑफ अ ट्रायंगल. सो वी हैव अ ट्रायंगल, ठीक है, एंड वी हैव अरिथमेटिक मीन्स ऑफ टू रियल नंबर्स, लेट्स से a2, geometric mean is j2 and harmonic mean is h2. Now if this represents the length of sides of triangle ABC, then we have to find the conditions on the ratio of arithmetic to harmonic mean. So we need a2 by h2 value. If it is known, the triangle is a right angle triangle. If it is known, triangle is a right angle. So let's see how to solve this. So since we already know it's a right angle triangle, तो यहाँ से जो मेरा वैल्यू आएगा वो आएगा a2 स्क्वायर इक्वल्स g2 स्क्वायर प्लस h2 स्क्वायर, right? Now from above inequality we know a2 square can be written as g2 square as a2 into h2, so a2 into h2 plus h2 square, which gives me, if I divide by h2 square, so a2 by h2 whole square minus a2 by h2 minus 1 equals 0. So we have t square minus t minus 1 is 0, which boils down to t equals 1 plus minus root over b square minus 4ac by 2. So we have 1 plus minus root 5 by 2. तो यहाँ से आप क्लियरली देख सकते हो a2 by h2 का वैल्यू is golden ratio which is 1 plus root 5 by 2. So it was a basic question, okay, of mains level. Now let's try more difficult questions of the relation between them. The second question is we have three positive numbers A3, G3 and S3, and they are harmonic, geometric and arithmetic mean of the sides. Okay, ABC of an integer triangle. So these three guys are arithmetic mean, G3 geometric mean and S3 is harmonic mean of sides ABC of a triangle such that ABC belongs to natural numbers. So we have integer sides of a triangle ABC and the harmonic mean, arithmetic mean and geometric mean of ABC is given. Okay. So now the question is, it is possible if and only if, so we have to prove like if the triangle is of integer length under this condition, the possibilities for A3, S3 and G3 exists if and only if this whole cube plus G3 by S3 whole cube is plus 1 is less than equal to 3 by 4 times 1 plus A3 by S3 whole cube. तो यहाँ पे एक inequality आपको दिखा दिया. तो अब देखो इसको हम कैसे शो करेंगे, क्योंकि ये एडवांस वाला डायरेक्टली दे कैन आस्क यू बाय प्लेइंग विद सम वैल्यू ऑफ A3 G3 एंड S3. यूजुअली दे कैन गिव फॉर इंटीजर साइड्स A3 वैल्यू कुछ न्यूमेरिक वैल्यू देगी, G3 दे कैन गिव न्यूमेरिक, फिर H3 पे बाउंड आपसे पूछ देगा लाइक द पॉसिबिलिटीज फॉर H3 एंड सो ऑन सो फोर्थ. आई एम सॉल्विंग दिस फॉर जनरल. तो यहाँ पे डेफिनेशन से व्हाट वी कैन टेल इज इफ A3 G3 S3 आर द स्टेटेड मीन्स, सो वी हैव A प्लस B प्लस C is A3. ABC, so this will be 3A3. ABC is G3 cube and 1 by A plus 1 by B plus 1 by C is 3 by S3. So now how we are going to relate A3, G3, S3. Now clearly we can see ABC fills root of cubic. So it's giving a fill of cubic kind of equation. So if I define a cubic like let's say PB to be B cube plus some constant C1B square plus some other constant C2B and plus C3 equal 0. And suppose the root of this equation is ABC. Right? So it's a cubic having root size ABC. तो यहाँ से by Wheater's formula cubic polynomial we already know A plus B plus C will be minus B by A minus C1 and that is 3A3. Sum of root taken to it is time AB plus BC plus CA is C2 and that according to the expression is 3G3 cube by S3. क्योंकि ये आप देख सकते हो यहाँ पे अगर LCM आप ले लोगे इसको, so we'll get ABC and A plus B plus C is 3 by S3. अब ABC we know G3 cube, so from here we got this relation, right? Third relation that I'm going to get is minus C3 equals ABC and ABC is already G3 cube. So we have these three relations in it. Okay, now just we need to manipulate and interpret this relation. So now from here we can write this expression or polynomial expression PB is B cube minus C1 is 3A2BA square and then we have 3G3 cube by S3 times B minus G3 cube. And these are only positive solutions to PB equals 0 because the only positive solutions for this is ABC. Since A3, G3, S3 are positive, right? So S3, G3 and A3 ये तीनों का तीनों positive है. तो यहाँ से what we can tell is we can write the given expression in this form also. We can make a perfect cube because यहाँ से we are getting a field of A cube minus 3A square times B. So maybe we'll add and subtract 3 B square A minus 3B square A. तो वहाँ से by making perfect cube we are getting B minus A3 whole cube minus 3 times. अब इसको you can check minus 3 times A3 square minus 3G3 cube by S3 into B minus A3 plus, of course I can do this using calculus also and with hint I'll leave it for you, but I am just trying to do it algebraically, right? A3 square plus the last term is going to give a3 cube minus g3 cube equals 0. Now we can make a substitution, u equals b minus a3, right? So we have u cube minus 3a3 square minus 3g3 cube by s3 times u plus leftover minus 2a3 cube plus 3a3 square by s3 minus g3 cube equals 0. Since all solution of this equation, u cube minus, let's call this as p, u plus q are real numbers, if and only if, now we know if all the three solutions of this equation will be real numbers. So for that we have a necessary and sufficient condition. अब उसके लिए हमको calculus का use करना होगा. So let's call this as a function of u. So what is f dash u? F dash u is 3u square minus p. So the critical point will be u equals plus minus root over p by 3. Right? अब यहाँ से if we'll put in the expression, so now we have a cubic expression. And for this to have 3 root, at infinity it's going to be infinity. Okay, so for this to have 3 distinct real root, clearly the output of the function at critical point must be of opposite sign. Okay, so at root p by 3, whatever answer I am getting, function value, so f of root p by 3 into f of minus root p by 3 should be less than 0. As long as it is opposite sign, it will definitely intersect at 3 distinct point. क्योंकि यहाँ पे जो height आएगा और यहाँ पे height आएगा, वो दोनों opposite sign के nature को होना चाहिए. ठीक है. इनफैक्ट पॉजिटिव पे हाइट नेगेटिव होना चाहिए, नेगेटिव पे पॉजिटिव होना चाहिए इस केस में, बिकॉज क्यूबिक अल्टीमेटली विल गो टू इन्फिनिटी फ्रॉम माइनस इन्फिनिटी. अब अगर आप ये वैल्यू यहाँ पे पुट करोगे, ठीक है, ये रिलेशन इफ विल कीप, तो जस्ट विथ सिंपल कैलकुलेशन यू विल सी दैट क्यू स्क्वायर बाई 4, क्योंकि ए स्क्वायर माइनस बी स्क्वायर के फॉर्म में चले जाएगा, विल बी लेस देन इक्वल टू पी क्यूब बाई 27. दिस इज नेसेसरी एंड सफिशिएंट कंडीशन. इट्स वेरी इंपॉर्टेंट. इट्स समटाइम्स यूज्ड इवन इन कोऑर्डिनेट ज्योमेट्री आल्सो. जब आप नॉर्मल फाइंड करते हो पैराबोला पे, नंबर ऑफ नॉर्मल्स ड्रॉन फ्रॉम अ पॉइंट वाले में भी, सिंस नॉर्मल इक्वेशन क्यूबिक बनता है, तो उस हिसाब से यहाँ पे आएगा. नाउ नथिंग मच इज देयर, जस्ट विल कीप दिस क्यू एंड पी. सो वी हैव पी दिस इंटायर स्ट्रक्चर एंड क्यू इज दिस स्ट्रक्चर, ऑफ कोर्स एक्सक्लूडिंग 0, बिकॉज द इक्वेशन ओरिजिनली वाज दिस इक्वल्स. जैसे ही इसको पुट करेंगे तो मेरे पास जो फाइनल आंसर आ गया, माइनस a3 क्यूब plus 3h3 square by 2h3 minus g3 cube by 2 whole square is less than equal to a3 square minus g3 cube by s3 whole cube. And this is precisely what we wanted to show. ठीक है, क्योंकि इसको if I'll open this a cube plus b cube, so we are getting a3 by g3 whole cube, ठीक है, और फिर प्लस g3 बाई h3 होल क्यूब प्लस 1 इज लेस देन इक्वल टू 3/4 टाइम्स 1 प्लस e3 बाई h3 होल स्क्वायर. ठीक है, तो दिस इज वेरी इंटरेस्टिंग रिजल्ट. अब जेई एडवांस वाला मे बी विल नॉट आस्क दिस क्वेश्चन इन फुल इंटायरिटी, लेकिन वो एक पर्टिकुलर वैल्यू दे सकता है. ठीक है, दे विल गिव साइड्स ऑफ ट्रायंगल एज ABC where ABC is integer, so based on this I have given, and they might give you a value of E3 or S3, 2 variables, and G3 पे any other means पे they can give ask about. ठीक है, अब usually these kind of problem आपको बुक में मिलेगा ही नहीं. ठीक है, क्योंकि most of this I have done in my college days, और जब मैं पेपर्स, ठीक है ना, रिसर्च पेपर मैथमेटिक्स में या फिर इंजीनियरिंग साइंस में जब मैं लिख रहा था, उस समय में इन सम कैलकुलेशंस इस टाइप के प्रॉब्लम्स अपीयर होते थे. एंड यू विल सी वेरी सरप्राइजिंगली लाइक एडवांस वाले इसी काइंड के स्ट्रक्चर्स पे काम करते हैं. ठीक है, सो आई होप आपको ये समझ में आया जो फंडामेंटली हाउ वी आर एबल टू पुट दिस इनटू एक्शंस. नाउ यू कैन आस्क थर्ड क्वेश्चन आल्सो. लेट मी गिव द लास्ट क्वेश्चन ऑफ a good variety. So in an integer triangle, again a triangle having integer sides ABC, the radius of incircle is 1/3 द हार्मोनिक मीन ऑफ एल्टीट्यूड। तो इसको आप कैसे प्रूव करोगे? द रेडियस ऑफ इनसर्कल आर, सो आर वी नो, आर इज एरिया ऑफ ट्रायंगल बाय सेमी पेरीमीटर, right? And what is semi perimeter? It's a plus b plus c by 2, where we have side length a, b, c. Now this can be proved very easily. R equal to triangle by s result you can prove very easily by sum of areas equals area of total triangle. Okay, अब देखो, if this is in circle, you can connect center of circle with these two vertices. So what is area of this chunk? Half into base into a small r. Similarly, area of this strip is half into base into a small r. And similarly, area of this is half into base into small. Now add all three area, that is area of triangle delta. So it is self proved. अब यहाँ से what we can see, अब देखो यहाँ से interesting result is how to relate with altitude. Okay, altitude might not be the point of contact of this incircle. So let's say how to relate. So we know half into base into height, let's say h1 corresponding to it, equals half into b into s2 equals half into c into s3 equals delta. तो यहाँ से h1 का जो वैल्यू है, और आई कैन टेल व्हाट इज द वैल्यू ऑफ a विल गेट 2 डेल्टा बाई h1, सिमिलरली b 2 डेल्टा बाई h2 and c is 2 delta by h3. So just with half into base into height, a b c is related with h1 h2 h3. So we have 2 delta divided by 2 delta by h1 plus 2 delta by h2 plus 2 delta by h3. तो अब तो मज़ा ही आ गया. तो फाइनली आंसर आ गया 1 by sigma 1 by h1, and this is precisely 1/3 of harmonic mean, because harmonic will be 3 by this quantity, so it's 1/3 of this is going to give the answer. Okay, so radius of incircle is 1/3 the harmonic mean of altitude. Now you might ask like why I am forcing this to be an integer triangle, क्योंकि I wanted you to do other questions also. This is true for any triangle ABC even if it is not an integer. ठीक है. Next one more you can try is in a right angle triangle with legs A and B and altitude h from the hypotenuse to right angle. So let's say we have a right angle triangle with legs A and B and this altitude is h. Right. We have to prove h square is half of the harmonic mean of a square and b square. Right. So we need to prove h square is half of harmonic mean of a square b square. मतलब हाफ टाइम्स 2 बाई 1 बाई ए स्क्वायर प्लस 1 बाई बी स्क्वायर. बेसिकली आपको ये प्रूव करना है ये एच स्क्वायर इज 1 बाई ए स्क्वायर प्लस 1 बाई एच स्क्वायर इज 1 बाई ए स्क्वायर प्लस 1 बाई बी स्क्वायर. अब दिस इज ऑल्सो इंटरेस्टिंग क्योंकि दिस यू कैन डू यूजिंग सिमिलैरिटी एज वेल और पाइथागोरस थ्योरम. For example, suppose if I directly use a basic idea, so let's call this length is x and this length is y. So now we have relation a square plus b square is x square plus 2xy plus y square by Pythagoras, which is x plus y whole square. और a square का वैल्यू इस ट्रायंगल से मुझे पता है, a square will be h square plus y square. Similarly b square is h square plus x square. तो अब तीनों को अगर मैं देखूँगा तो इमीडिएटली इट फॉलोज ए स्क्वायर का वैल्यू क्या आने वाला है. ए स्क्वायर इज एच स्क्वायर प्लस वाई स्क्वायर. राइट. सो एच स्क्वायर इज ऑलरेडी बी स्क्वायर माइनस एक्स स्क्वायर, सो प्लस वाई स्क्वायर. नाउ व्हाट अबाउट ए स्क्वायर प्लस बी स्क्वायर. सो ए स्क्वायर प्लस बी स्क्वायर will be b स्क्वायर माइनस एक्स स्क्वायर प्लस वाई स्क्वायर, एंड दैट इज एक्स स्क्वायर प्लस 2xy प्लस वाई स्क्वायर. तो यहाँ से आप देख सकते हो वाई स्क्वायर का वैल्यू जो है वो कैंसिल हो गया. राइट. वाई स्क्वायर गॉट्स कैंसल्ड. फिर सिमिलरली ए स्क्वायर को आप कनेक्ट कर सकते हो, और जैसे ही कनेक्ट करोगे देयर आफ्टर यू कैन सी एच स्क्वायर इज 1 by square plus 1 by b square. So these were very standard result, where you see how geometrically we can relate this AMGM and HM inequality. So I hope you must have enjoyed the lecture, and I'll come with more interesting and quality content for you for free on this YouTube channel. Please do like and subscribe if you want to enjoy more such good content.